Welcome everybody. Thank you for inviting me. So today I'm going to talk about how to assemble GenAI solutions in a visual way, so without any coding. 2 words about me, just to show that I didn't pop up yesterday. So I'm Rosaria Silipo. I work as a data science evangelist at Knime. I have tons of years of experience in the data science space, so GenAI is just the latest innovation in the space. I've worked as a data scientist, a data engineer, and a data analyst in finance, healthcare, so I've been around all sorts of professions related with data. And currently, I'm working on use cases with GenAI, so that's I'm trying to find new use cases that could be solved with GenAI. So the goal of this workshop, I developed some time ago an application for fraud detection. This application was based on classic data science techniques. So the goal of this workshop today, I'm going to show you how to create a fraud detection application. And I will mix classic data science techniques with GenAI-based techniques. Because, well, we can discuss that later, but for some things, applying GenAI might not be worth it. For some things, GenAI is perfect. So you will learn today about fraud detection, some of the classic techniques for fraud detection, and then something about accessing GenAI large language models, and all of that without writing one line of code. So the agenda, I'm going to introduce the use case. So the fraud detection on investment contracts. It's on investment contracts because, of course, I had to fake the data. The original project was about fraud detection on invoices, documents. But, well, I had to change it because, of course, I can't share the data from the customer. And then after that, I'm going to give an introduction to Knime Analytics platform because, as I said, we will implement this whole use case without writing any line of code. So to do that, we need to rely on a low-code platform, which is, in this case, Knime Analytics platform. Then, of course, I'm going to explain how the AI extension works for Knime Analytics platform. I'm going to show how to prompt a GenAI large language models via API, and then how to implement a retrieval augmented generation process. Okay, so I don't see you, so if you have questions, either you interrupt me or I'll answer all of them at the end. So the use case, fraud detection on investment contracts. How does the fraud detection process work? In this case, we have a document that is created. In this case, it's a contract. It reaches the bank or some kind of a controller institute. This controller institute goes through all the documents that has received that day and finds the few documents that somehow are suspicious. You find these potential frauds, and then they send some kind of information email, some warning email to the customer, and usually it has to be in the customer selected language. So it's not only in English, but depends on what the customer has selected as the preferred language for communication. So when we talk about fraud detection, there is a different perception by humans and by the machine. So for us, for humans, fraud is an intentionally deceptive action. So that includes some kind of a moral judgment, an intention to do something bad, for a mean action. This is, of course, not possible for the machine. So fraud is let's talk from a human point of view, impacts people, industries. Of course, it's a big problem. The common types of financial fraud are frauds for tax evasion, that's the invoice part or the contract part, credit card transactions, of course, securities, insurance frauds, of course, and then bankruptcy frauds. Those are just the most common and most impactful area where financial fraud can happen. There are 2 types of financial frauds. There are the one-shot big money fraud. So somebody cleans up your account with some kind of deceitful signature on some kind of document. And then so this is actually the easiest to find because it's a huge amount with respect to what you usually spend. But then there are also other frauds that are, tiny, small amount of money, the $1 each month, that on that month, on that person doesn't make a huge difference. But then if you repeat that for many years and for many people, then it has a big impact on society as well. So there are these two types of frauds. And of course, the second type of frauds with the tiny amount of money, frequent tiny amount of money, it's harder to detect, right? Because it's $1. Who cares about the $1? So what I want to do today, I want to detect wrong, maybe fake contracts. So I start with a data set of PDF files of contracts. The contracts, they are all made according to a template with some legal language in there. The only thing that changes for each contract is the serial number, the date, and the amount of money. And then, of course, the name of the people involved in signing the contract. So those are the main things that we can check to make sure that the contract is actually is a potential fraud. So the amount of money, the serial number, the date, and then all the anagraphics of the people involved, the address or the name or stuff like that. Of all these contracts, I want to find the suspicious ones. So there are 4 contracts in this data set that are actually frauds. So I want to see if I can find all of them, at least as suspicious contracts, or maybe I find more, it depends. So as I said, there is a different perception between humans and the machine. The machine doesn't have this moral judgment. So the only thing that we can find with the machine is an outlier. In statistics, an outlier is a data point that differs significantly from other observations. So what I can find is only that data point, which is weird with respect to the other data points. Now, if it's a fraud or not, if there was some malignant intention behind that, I cannot say, but I can isolate the outlier. So what is an outlier? Here you can see a bunch of data. They are all somehow close to each other. There are areas with high density of data, but then there is one point that stands alone somewhere else, far away from all the other areas densely populated, and this is the outlier. So an outlier is something that is distant enough, that is different enough from all the rest of the data set. So outlier detection techniques are often used for fraud detection. So the techniques for outlier detection, there are many. So we have the easiest one are the visualization. Like before, you visualize the data set, you find those lonely points, and those are the outliers. Otherwise, we have statistics-based techniques, clustering-based techniques, machine learning with the isolation forest, deep learning techniques like using the autoencoder, the neural autoencoder. So there are many different techniques, and those are the ones working on numerical data. When you work on, let's say, addresses that don't exist, people that don't exist, then in this case, you go with the string similarity matrix, like you would do, for example, to correct the typos in a mail address. And so those are the string similarity matrix allow you to spot something that is not correct in the nominal data. But for today, we limit ourselves to do the numeric data because otherwise I don't have the time in 1 hour to show also the GenAI. Okay, so let's focus on the statistics part. So the fraud detection process then includes reading the contract data. Is there an outlier or more? If we find a few outliers, then we find the customers that are affected and we send them an alert email, a warning email. So the part we can use GenAI either to find the outliers or to create these email texts. I use the GenAI to create the email text because that's what GenAI does best. I also used it to detect the outliers, but this one somehow was not that successful. If you want, we can discuss that more. I mean, it worked, but sometimes it worked, sometimes it didn't, and I couldn't control the process well enough to make sure, that I knew what I was doing. While on the email generation, it was much better. So let's talk about Knime Analytics Platform. Knime Analytics Platform is a platform, a tool for data science. So it covers all your operation around data, from machine learning to building dashboards, from data acquisition to building a data warehouse. So all these kind of operations are all covered within Knime. It's low code, so you don't need to code. It's all based on these blocks that you drag and drop, and you put in a pipeline one after the other, and so you obtain this kind of workflow. So you don't need to write any code. Of course, if you want to write code, we have an integration with Python, we have an integration with R, with Java, with JavaScript. So if you want, it's possible to write code, but it's not necessary. So there are a lot of these blocks that allow you to build complex applications without coding. It's open source, and that for many people means that it's free. So you can just go onto the knime.com webpage, download it, and start playing with it. Okay, so I'll give you a little bit of an introduction. This one I've already said. So the smallest computational unit in Knime is the node. The node is these little blocks. I already said you drag and drop it into the workflow editor, and then you put together, one node after the next, and you build a pipeline of nodes. A pipeline of nodes is a workflow and takes your data from A to B. A could be the data acquisition, and B could be a dashboard, could be the training of a machine learning model, could be a data warehouse in a database, I don't know, so it could be something around data. So let's talk a moment about nodes. Nodes are these little blocks. Every node is dedicated to implement a specific task. In this case, we have a table splitter. So based on some criteria, the table splitter is going to split the input table into two output tables. So that means that it has an input port where it receives the original input table, and then it has two output ports where it produces the two resulting data tables. Based on some criteria, so that means that there is a configuration window. You double click on the node, the configuration window opens, and then you're supposed to define the criteria for the splitting of the data. Of course, every node implements a different task, so every node will have a different configuration, will require different configuration settings. A reader node that reads a file will require the path of the file. A machine learning model that trains a model will require the parameters of the model, of course. So, but all of them, they have this configuration window that allows you to customize the execution of that particular task. Under each node, you have this little traffic light. It's a status. It's the status of the node. So, of course, when the node is created, it doesn't have the settings to perform the task. So the traffic light is red. When the node is then configured, so you have assigned the settings for the node to perform the task, then the traffic light is yellow. Then you right-click and select execute, for example, and if it executes without any error, you have a green traffic light. If you have an error, then you have this red circle with the cross in the middle. So this is to recognize the status of the node. We define the data science life cycle. We divide that into parts, the creation and the production. The Knime Analytics platform tool is for the creation, so allows you to create the applications around the data. And then we have a second tool, is the Knime Business Hub, that provides you with the IT infrastructure to do an easy productionization. Now, who needs an easy productionization? That's for the companies, right? For this, if you have a lab and you have 200 workflows to run every day, and maybe there is even some kind of a hierarchy in the workflows, and who runs first, or who has to wait for the successful execution of another workflow, which people in your group have the right to see which results. So all these complicated things that, of course, belong to an enterprise setting, and the Knime Business Hub gives this IT support for the productionization at the enterprise level. This one, the Knime Business Hub, is not open source, and that's the one that pays our salaries, basically. Okay, so a question that I heard often is, but if Knime is low code, can I only solve like toy problems? Is that limited in its, in the data operations that it can cover? So the fact that Knime is open source, that means that we develop the core of Knime, and then there are a number of research institutions, like, for example, Harvard universities. They provide extensions to enlarge, to expand the Knime capabilities. So including the extensions provided by external research institutions or academic institutions, Knime has more than 4,000 nodes. So I'm sure you can find the task that you need, even if it's DNA analysis or cheminformatics or some other, or process management or some other kind of niche data analysis. So with the extensions, it becomes a very powerful tool. I'm going to give you a little bit of a demo now. So, okay, I don't see any questions. So, okay, I'll continue. So this is Knime Analytics platform. Here you have the editor. So where you assemble all your nodes and then you build the pipeline, the workflow. Here you have the node repository. This is the list of all the nodes that Knime Analytics platform offers. Of course, you can see only the most commonly used. So if you want if you need a special node that is not that commonly used and it doesn't appear in this list, then you, for example, let's say it's an aggregation, then you write in the search box what you think should belong to the description of the node, and then you are going to find all the aggregation related nodes, for example, the row aggregator. I wanted to show you these 4 tabs here. They're a bit tiny, but they're important. So the first tab, the first tab is this node repository. We have seen that already. Sorry, the second tab. The first tab is the description it's a description panel. For example, if I select this node in the workflow, then the description panel pulls up the description of the task implemented by this node and the description of the configuration settings, the ports, the input and the output of the node. If nothing is selected, then there is going to, if anybody has written the description of the workflow, then it's going to show the description of the workflow. The third one here shows you your space with all your projects. So those are all my projects. Yeah, so you can find all of them here. If you are new, you are going to find only these example workflows, which is what comes by default together with a new installation. And then the last one is this one comes only if you install the AI extension, and it shows the Knime AI assistant. If you are lost and you don't know what to do, you can type here a question, and then it's going to tell you which nodes does whatever it is that you have asked. You have 2 modes. One is the Q&A mode, and the other one is the build mode. The Q&A gives you an answer. The build might try to build the workflow according to your request. It doesn't work 100%, but it can give you a little bit of a skeleton of the workflow that you want to build. So for example, if I want to build a new workflow, then I go here, I say create workflow, I give it a name like demo workflow. Okay, so I say create, and then I end up with a blank workflow editor because there is nothing. So let's go back into the famous example workflows that you should have since the beginning, since your first installation. If you go under basic example, now these are here. If you go under the data, you can find a bunch of data sets. So let's take the adult data set. It's a CSV file. If I drag and drop the data from my workspace into the workflow editor, then since it's a CSV file, he knows that the node associated with the CSV file is the CSV reader. It also actually populates already its configuration window with the required settings, like for example, the path of the file. And then you have here a little preview where you can check if what has been read is correct. It seems correct, so you say, okay. Now to execute, either you use this button or you use this button, or you do right click and use execute. They're all the same. And then since it was successfully executed, you get the green light. Notice here the node monitor. This one gives you a view of the data produced at the output port by the node that is selected in the workflow editor. So in this case, we have as output the data that have been read by the CSV reader. And then, of course, you can comment, you can write reading the adult CSV file. You can also write some annotation. So new workflow annotation, then you write these annotation explains, I don't know what this workflow does, stuff like that. You can make it bigger, change, I don't know, if you're artistically inclined, you can change the color, you can make it, I don't know, that's a little bit of an editor, you can make it bigger and so on and so on. So I'm not artistically inclined, so I'm going to skip this part. Okay, so, and then let's suppose that I use the aggregator node that I found before. So I drag and drop, then I click here, I release here, and I connect the two nodes. I open the configuration window of the row aggregator with a double click, and then I select what I want to do. Let's say that I want to calculate the average age of men and women in this data set. So let's include only the age. Let's calculate the average, and then let's calculate it by sex here. Okay, so let's now close it. Let's execute, and then if you check the node monitor panel, you can see that the female have an average age of almost 37-year-old, and the men, they have an average age of 39-year-old in this data set, and so on. And then you keep adding nodes, and then you can make even very complex applications. Okay, so this was just a very, very tiny demo. Let me start again. Okay, so how do I implement outlier detections? In this case, I'm going to implement just the interquartile range technique. So you know how a box plot is implemented, right? The box plot is this box that is drawn in the chart, and the box is drawn between the first quartile and the third quartile of the data. So this gives you a bit an idea of the range extension of the data. So if you calculate the distance between the first quartile and the third quartile, this is called the interquartile range. The idea of an outlier is something that is very far away from the third quartile or below from the first quartile. So how do we translate this very far away? Everything that is k times the interquartile range above the third quartile and k times the interquartile range below the first quartile, this is identified as an outlier. It's as easy as that. Of course, if you check the value of k defines how tolerant you are to outliers. A low k allows you to discover more outliers. A high k allows you to discover only some outliers. So of course you can be you can play a bit with this factor k and become less or more tolerant in discovering outliers. Usually k is defined 1.5, but you can choose whatever you want depending on how strict you want to be. So this interquartile range technique is implemented by this numeric outliers node, and the box plot is implemented by the box plot node. So the numeric outliers node, now this is the configuration window, you can check it, and then you can see that the multiplier k is supposed to be defined. There is a default value 1.5, but you can change it. And then you're supposed to indicate which numerical column you want the interquartile range technique to be applied. So this is all the configuration window requires. So let's see. At this point, we said that we were supposed to read the contract data, find the outliers, and then for the outliers, send an email to the corresponding customers. So for the first two parts, we have this little workflow here. The contracts are in PDF files, so we use the PDF parser node. Then we extract the data from the PDF files. Then we rescue the customer that is associated with this contract from our customer database. We put all the information together. Here there is some visualization. This one is a component. A component is a node with inside other nodes and has this great property that if you have graphic nodes inside the component will have a view including all the views of the graphic node that are contained. So you can build a dashboard basically with a component just by including these plots and charts and widgets and other things and shaping the dashboard in the way you want according to some kind of a grid format. Anyway, but I'm not going to talk about the visualization today. So after that, I introduced this numeric outliers node that we know it implements the interquartile range technique, finds the outliers according to k equal 1.5. And then what do I do with these outliers that they are found? I will send an email alert. So here I could have used GenAI instead of the numeric outliers technique, I mean, I did use it, but it didn't work. So basically, depending on the prompt, I would get 2 outliers, I would get 3 outliers, 5 outliers, 6 outliers. There are 4 outliers in this data set. So I mean, at the end, I would get a random number of outliers. Some of them are real outliers, some of them are not. And frankly, I don't know why. I don't know why changing the prompt would give me different number of outliers. I don't have a parameter k that I can change, and then I know that I'm going to find more outliers or less outliers depending on this k. It's just very random what GenAI does. And I mean, at the end, you have one node, it's already there, you drag and drop it, it works. So why should I invest too much time in controlling something that is not easy to control? On the opposite, GenAI works very well for generating text. That's why GenAI was created. And so I'm going to use GenAI to create the text for the warning email. So the first usage of GenAI is to query, to prompt via API large language models from an AI provider. So why am I saying that this generating of email alerts is much easier than, it's more convenient than using GenAI for outlier detection? Before, when GenAI was not available, what we would do, we would have templates. And then, you know, you would have this template in the different, let's say 100 languages. And then you would, let's say the language of the customer is Russian. You find the template for Russian. You change the variables in the template, like the amount of money, the name of the customers and stuff like that. And then you send the email. Now, creating that the first time is not so complicated. I mean, it's complicated, but you can do it. The problem is the maintenance, because if you have 100 languages and let's say you need to insert a different clause because GDPR in Europe has started or something like that, then you have to add a little piece in 100 different languages in 100 different documents, of which most of them you don't understand. So you need to pay somebody, and you need to trust this somebody to perform this update. And you know, updates happen all the time, so it becomes complicated. With AI, it's easy, because creating a text for 2 languages or creating a text for 100 languages is the same. I mean, it's the same time, it's the same thing. The only thing that changes is the language for the generation. So it's definitely a time saver. And I trust GenAI enough to produce a text that makes sense. So let's see if I was correct in that. So to prompt a large language model via API, I need 3 steps. First, the authentication to the AI provider, then connection to the large language model, and then sending the prompt. So it's really 3 nodes: authenticator, connector, and prompter. Of course, before that, we don't provide any user creation or API key creation in Knime. You need to register with the AI provider, whatever you choose. You need to create a user and a profile, and then from the profile, you need to extract the API key that then you can use to query the large language model. So this API key would be stored in this credential configuration node, which is all protected and you can't see anything. And then you would create this prompt for now in this table creator would be something like create a text for a warning email in Russian, for example. Yeah, and then those are the 3 nodes that you need: authenticator, connector, and prompter. That's quite easy. So this one, of course, it's for any AI provider. OpenAI is one of them. We have the authenticators. We have a bunch of connectors to different language models, and then we have a bunch of prompter to query the different language models. But the same is we have it for Hugging Face, we have for Azure OpenAI, and if you want to use one of the latest language models for which we don't have pre-packaged nodes yet, you can still do it by using the REST extension, using the GET request and POST request nodes. and querying via OYAMA, via the OYAMA package. Okay, so if we decided to use OpenAI, because I already have a user there, a user profile there, so that's what it becomes if you use the OpenAI. You are going to have the OpenAI authenticator and the OpenAI LLM connector. And this is the prompt. Write an email in Russian to this customer, name of the customer, with the following requirements. And then there are a number of requirements, for example, authoritative tone or something like that. And this is the response. Now, this one is in Russian. I don't know how many of you speak Russian. So this is the similar for another customer in English. So you can see, you can take your time and read it. I think it's okay. It's good enough. It's definitely better than what I would create. So for me, it's good enough. Maybe could be a bit more legalese, maybe. But I mean, as just a general text that I just query and LLMs without any training, without any other kind of preparation, I think it's good enough. Okay, so the problem when we talk about GenAI, we can't avoid talking about hallucinations, right? So hallucinations is the large language models, they always give you an answer. Now, if the answer is correct, completely wrong, or just partially wrong with a bit of things that are not correct, like for example, everything is correct, but the ear is not correct, or it's completely wrong because it is answering something completely different, those are all hallucinations. For example, if you want to ask about Knime nodes on for a Knime workflow on ChatGPT, sometimes he answers correctly, but sometimes he makes up the name of the nodes. So he says that there are nodes that they actually don't exist. So I don't know. You have to take it a bit. Yeah, that's what ChatGPT does. So this is a spectrum of common types of AI hallucinations, from the easiest to recognize, so the complete nonsense, to on the right, the most complicated to recognize, because this one sounds correct, it's mostly correct, but there are a few contradictions that if you don't know the facts, you cannot detect. So large language models are prone to hallucinate. They will give you an answer anyway. How can we mitigate these hallucinations? How can we, I mean, also because sometimes we prompt for things that we don't understand. So we need to trust what it says. So one possible mitigation with could be by implementing a retrieval augmented generation, the RAG process. Retrieval augmented generation is a process that tries to optimize the output of a large language model by referencing an authoritative knowledge base. So basically, we give him a prompt which is slightly guided by an authoritative knowledge base. What is an authoritative knowledge base? It's a set of documents that provide factual information or correct information or the right terminology to use in that field that make the answer of the large language models a bit better, a bit more accurate, a bit more precise in terms of terminology. So in our case, do we have an authoritative knowledge base? We had the description of the various contract types. So those were contracts about investment funds. So we had all the descriptions about the investment funds that people could apply for. So we decided to use these descriptions as our knowledge base. So let's see how the retrieval augmented generation process is implemented. Again, the process is the same. We access the data, we detect the fraud, we create an email alert by asking the large language model, and then the large language model.
Rosaria. Yeah, sorry to interrupt you. So we have one question in chat, you can see. Okay. And I hope everybody is enjoying this session. So guys, if you have any doubts, ask as many questions as you want and clear your doubt and get most out of this. Yeah. So yeah, we have one question, Rosaria. So can you please look into it?
Is there a line that you could draw in the previous slide that splits the nodes into ones that are system specific versus one that are universal? What do you mean in the AI part? I think that's the slide, is the one with the AI part. Yeah, that was around slide 17. Okay, so let me see. I think that's the one about the AI on slide 17. This one here, no, it's not the AI. So this one with the 4,000 nodes. They are all general. I'm not understanding the question. So let me see. Let me understand a bit better. They're all, so that in theory, they all work on all systems. If you mean system specific, like operating systems, then they all work on Linux, on Mac, and on Windows. So if that was the question. So there is no specific nodes. Some of the extensions, sometimes they work better on Windows rather than on Mac, but they are a bit specific. Like, for example, the DNA analysis, because they use libraries in Python or in other languages that are more, they work better, for example, for Windows. But the core stuff works on all operating systems. Okay, so another one is, what is the point of making $1 float? It's too small to be valuable, and it's very easy to detect. It happens frequently, would definitely notice. I don't know, they do it. I actually was a victim of that. So somebody kept collecting €1 for a long time. I mean, at the end, for me, it was not a lot, but if they do it for 100,000 people, then it is a damage. I mean, at the end, I guess they are happy with getting some money from you. It does happen more often than you think. What do you want me to say? I'm not a hacker. I'm not in the head of hackers. So, okay. So what else? Why for the multi-language support, you cannot conduct all data mining and analysis in English, and as last step, translate using Google and Amazon. Yeah, sure, that's another option, but you still need a service, right? Even the Amazon Translate API, it goes by GenAI, right? So it's I mean, you can ask to generate it since the beginning. With GenAI, yeah, sure. You can also generate it in English, and then you can do the translation, or you can ask to generate it directly in the language that you want. I would prefer to generate it directly in the language that I want because it's less steps, so it's more elegant, but it's not incorrect to do, as you say. Like nodes that are specific to certain systems. So the nodes that are specific to, so if it's for the type of files that you want to read, those are all reader nodes or database nodes. Okay, so let me share a bit here. So if you go, okay, so now here, those are all the IO nodes. And if you want to show all of them, so those are the ones that are related to files, right? Right. So, and then you have the other nodes. They are now, I have to go towards the end. So let me find it again here. So yeah, so then you have the other ones for the transformation. So all the raw filters, those are the yellow ones. Maybe it's the color code that you mean. So the color code yellow is for transformation. This kind of orange brown is for data access. Red is for writing. Blue is for visualization, and then machine learning is all shades of green. And then the database, all the databases, they are the same. So if you have to connect to a database, or if you have to read data from a database, or if you have to perform a SQL operation on a database, so they inherit the same color as the operation on data, the access on data, the writing of data. Does that answer the question? Yeah. Yeah, so those are, usually it's a lot of yellow in a lot of this. And then you have also, if you want to go further and you want to go into the control. So for example, I don't know if you noticed, but now I don't have the time to do a full question, but the triangular black triangles, those are data ports. So data in, data out, but then there are also these circle, the red circles, those are flow variables. Flow variables are parameters. So you can run a workflow, let's say for US, and then you change the parameter country for Germany, and the whole workflow runs again for Germany, right? So it's those are the parameterization. The light blue here, those are loops, so that there are many things. Yeah. Okay. Okay, so okay, I'll continue then. I think there are no more questions. Because I wanted to be able to finish the RAG. So let's see. I think it was here. Yeah. Okay, so this is the same steps. Those are the same steps as before, but the difference is that now I want to insert a knowledge base when creating the response. for the large language models when creating the prompt to pass to the large language model. So you remember it was 3 steps: authenticate, connect, prompt, right? But now I want to inject the knowledge base, for example, the description of the investment type, right? So I want to pass a prompt that says create an alert email by using the description of this fund. Okay, so what do I need for this kind of things? I need the knowledge base. I said that already. For good luck, I have it. If you don't have the knowledge base, you cannot implement RAG. Then I need an embedding model. An embedding model is a model that processes a document and transforms a document of words, of text, into a vector of numbers. So we say that the embedding model transforms the document into a point in the vector space. Now, 2 documents that are similar semantically, so they talk about the same things, they create 2 vector points in the vector space which are close to each other. So similar and semantically similar documents produce close data points in the vector space. This is useful because it makes the search much faster. Okay, so then after I have this embedding model, I need a vector store to save all my documents. And then this vector store, it will contain all these numerical vectors that have been generated by the embedding model. And then as last, I will need a retriever operator that, given an input document, finds in the vector store the document that is the closest, the point that is the closest. Okay, so 3 things: the knowledge base, 4 things: the knowledge base, the embedding model, the vector store, and the retriever operators. So those are the 4 things that I need. The knowledge base I have. Now let's see the other 3. So the other 3 means that there are 3 nodes. I need an embedding connector. You remember we had the large language model connector. This one is another connector connecting to embedding models, to these special models that don't give you an answer, but they they transform the input document into a numerical vector. Then I need the vector store creator, which is the one that basically saves all this numerical representation inside a space. And then I need the vector store retriever that has another document as input, is connected to the vector store, searches inside the vector store, and finds the points, the documents that are the most similar to the input document. Is it clear? So again, 3 more steps to implement the RAG: connect, create, and retrieve. Connect to the embedding model to perform this numerical transformation. Create the vector store to include all the points produced by the knowledge base once these documents have passed through the embedding model. And then the vector store retriever to find the closest document in the vector space to the document at the input port. So those are the 3 nodes.
A question?
Yeah.
So is there, for the embeddings, when you store it in the vector, where is there an indexing happening after the embedding is created for the documents that you have in your knowledge base?
So there is an indexing, but what happens now, I don't have the slide here. What happens is that similar documents are going to be stored close to each other. So you do a localized search. So I had an example that says, who won the World Cup, right? The soccer World Cup. So this is the prompt, let's say. Then you have 6 documents in your knowledge base. The first document says that the Oscar was assigned to. Completely different stuff. In the vector space in the vector store is very, very far away from where your prompt ends up being. Then you have another news which says Argentina won the World Cup. So this one is going to be very close because it's soccer, because it's winning, because there is a World Cup. Then you have another about Bayern Munich, I don't know, winning something European stuff. And this one is still soccer, it's still winning, but it's not the World Cup, so it's going to be a bit farther away. So the thing is that you, at the end, you just have to do a distance calculation between the points, and you just have to find the ones that are the closest to you, and you don't care about the ones that are the farthest away. That's why it's so fast.
So the retriever will have something like a nearest neighbor algorithm or something like that for that.
Yeah, something like that. Yeah.
Okay, thank you.
Yeah. Okay, and this one is the final workflow. So again, you start with your API key, then you get authenticated as a user on your AI provider, then you connect and select the large language models. You connect the large language models to the prompter, but then to create the prompt, this time you inject some knowledge base via these embedding connectors, the vector store creator, the vector store retriever, and then at the end, you put everything together and you pass the prompt to the large language model. So the answer is going to be, in theory, a bit more correct and a bit more precise. So let's see how this answer was. This was the answer with RAG, so not just purely API request. And what's the difference? The difference is here. It says it gives a bit you more of a legalese kind of stuff. And it says, as you may know, the statutory stock option agreement is a type of contract, and it tells you a bit a summary of the contract that supposedly you have signed for. So it's a bit more precise. It also, the terminology is more correct than what it was created before. Okay, so what does the Knime AI extension contains? Contains the authenticators. We have seen them already, a bunch of connectors to different language models, prompters for embeddings and for large language models, embedders, and then, of course, vector stores nodes related to the vector stores and agents to create the chat, the GenAI chat. So this is the final workflow. The first part, you read the data, you do some pre-processing and cleanup of the data. You use the numeric outliers node for the fraud detection. Maybe you do some visualization if you want or not or whatever. And then the second part is about generating this text, this email, warning email. So in this first part, we just query the large language model via API, so free prompt. And in this second part, we use RAG to get a better answer, especially with a more accurate terminology. Yeah, and that was the result of the final answer. So I don't think I have the time to show you the deployment. I don't know, unless I have 10 minutes. Let me see first the questions.
You have 7 minutes. See, one quick question. So all this Knime platform, you said it's open source and it's free, including like everything, including all the connectors and vector store and everything.
So the only, of course, you have to pay your AI provider. We don't provide that.
The LLM for the embedding.
Yeah. Yeah,
Okay.
so you have to subscribe to your AI provider and pay. Probably they want your credit card, but our stuff is free.
But you can connect to anything like Cohere or any like open ChatGPT or any of those LLMs.
Yeah. So we have some prepackaged nodes. Those are the ones that you have seen. We are always a bit behind in the new models that come out. But if you use Oyama, you can use the REST GET request node and the post request node using the REST API via Oyama.
Okay. Yeah, let's go through the deployment quickly if you don't mind.
I missed the beginning of them. I'm interested now you could query the data without using GenAI to do the query if the data is not in tabular form. What do you mean? Like using a database node? I will answer this one later. I have to understand the question. Professional criminals are a bit more clever than of course, yeah. This is just a tutorial. Yeah, of course, but that's also a very good point. Professional criminals, you're always one step behind them. And that's actually why you cannot use machine learning to prevent fraud, because the fraudsters are always one step ahead of you and you don't have enough examples of how they do fraud. Absolutely true. This is, of course, just a little example. I mean, it's a tutorial. But you can do something more complicated. You can do it on many dimensions. Anyway, we can talk about that. Okay. The AI extension is free. Oyama, what is that? Oyama, that one, exactly. Thank you. It allows running language models, exactly. I see that you have already answered. So let's go quickly through the deployment. So the deployment, you do everything in your lab, you have your data set, everything works. I know that there are 4 outliers in that data set, so I know more or less what the answer should be. That's why I was not convinced about the GenAI response, but then there is the real world. So what do you do with the real world? You take the model you have created in the lab, and then you applied to the contract that comes tomorrow, the day after tomorrow, and then so on. So you cannot every time recalculate the whole numeric outliers. That's of course not possible. So, sorry. So you save the models, in this case, there are two, and then you apply and you reuse them for the everyday analysis tomorrow, the day after tomorrow, until they become too obsolete. So here, if you notice, there is a model writer out of the numeric outliers, and then there is another model writer there that saves my vector store. So let's keep that in mind. So the deployment workflow, what does it do? It takes another contract. So let's say we are tomorrow. It takes another contract, the new contract of the day, parses it, imports it, and so on. Then finds again in the database the customer with the language that he chose for the communication. Then you take the model that you have saved from the numeric outliers, you apply it, and then this model is going to tell you if, according to the statistic that you built yesterday, this contract falls in the outlier category or not. Let's suppose it falls in the outlier category, then you retrieve the vector store that you have saved yesterday. You again connect to your user, to your AI provider, choose the same large language models, and then you apply the same vector store retriever as yesterday, but this time you don't need to rebuild the vector store because you have built it yesterday. Inserting in the prompt, send the prompt to the large language models, and then you get the preview. So the deployment, I always say it because sometimes people they think that, you train a model and everything is there, but it's not true. You train a model, you build a vector store, then you freeze it, and then tomorrow you will connect to it and reuse it for the new contracts. Otherwise, of course, it's a waste of time and the statistics would be ruined. But this is yeah. Okay, and then if you want to run it on the Business Hub, on the Knime Business Hub, and you want to have all this IT infrastructure that allows you for scheduling and automatic running and triggered running, and if you want to have permissions of who can run it and who not, then you just move it onto the Knime Business Hub. If you want to do an ad hoc execution, you just click run here and then run it. Otherwise, you can schedule it. You can do a bunch of other things. It executes and voila, you get the visualization of the email, the text email that you have created on a web browser. And this is it. Okay, so I'm close to the end. So those are the slides. I sent the slides to the organizers of this meetup. So if you want, you can get the slides. If you want to get the scanning here, the QR code, it takes you to this tiny URL where we save the GenAI exercises. As I said, this is a tutorial, so of course it's very simplified. Otherwise, it's going to take forever. Next time, if you want, I can do a use case, but then I don't go into all the details. These workflows are all saved on the Knime Community Hub. Is another free storage repository for the Knime community. If you create an account on the Knime Community Hub, then you get, I think it's 50 gigabytes for your projects. But the nice thing is that you can post there your projects, but you can also download the projects that somebody else has created. There are a lot of people and they all put their projects on the Knime Community Hub, so you can find examples for whatever you need to do. This is the link, and those are the exercises and the solutions that we created for this tutorial. If you want to learn more about Knime, we have courses, so there are self-paced courses, they are free. There are instructor-led courses, they are not free, they are online, so they don't cost much, but so they cost something. The courses are organized in level. You start from the L1 with the basic proficiency, then you move to the L2 for the advanced proficiency. The L3 is about the whole productionization, the whole deployment. And the L4 are specialization. So that means like algorithms or data engineering best practices or data visualization, do's and don'ts, stuff like that. And then at the end, you become a certified Knime data analyst, a certified Knime data scientist, and so on. Those are the certifications. We have also, if you go into the Knime Press, we also have cheat sheets. We have now 13, 14 cheat sheets. They are dedicated to a topic. The first one that you should download is the one for beginners. But then you have, for example, the cheat sheet about machine learning, the cheat sheet about orchestration, the cheat sheet about data visualization, geolocation, we are planning to make one about AI, of course, it has to be. And then we have the Knime Press also produces books. The textbooks are the ones where you learn. So there is the lesson, there is the exercise, classic textbook. And then you have the collections, either technical or for use cases. And then if you come from other tools, so you can use one of our transition booklets. And I think this is it. Yeah, you can find us on YouTube, well, the usual. I also hold a podcast on LinkedIn. It's called My Data Guest, where I invite 9 professionals to. The next one is going to be about how our job is going to change with the introduction of AI, because, well, it's going to change. Yeah. Yeah, that's it. So then, well, we have the Knime forum, and then, of course, we have the usual suspects for connection. So I'll post. Just a second, I'll go back and I'll post the QR code so that if somebody missed it. Yeah. Okay.
Thank you, Rosaria, for your wonderful session. I hope everybody has enjoyed your session and got some insights. I can see a few more questions if you can see in a group chat.
Yeah.
And guys, if you have any more question, you can ping in a group chat and get the most out of it. You still have time. You can ping in a group chat.
It's all thank you. So there was this question, do you have any methods to protect private information from being passed to OpenAI? Very good point. I didn't talk about that before. So if you don't want to send your information to OpenAI, it's possible to, for some extensions, for example, ChatGPT for All has it. You can download the models. So instead of having authenticate, connect, and prompt, you would have download on your machine, then connect without authentication, and then prompt, and then the whole thing remains on your machine. I didn't present that today, but it's possible, of course, it's possible. Yeah. So running open, it's also possible if you want to anonymize the data. I mean, you don't need to send all the data. There are no anonymizer nodes, so you can also use the anonymization nodes, absolutely. Running open source LLMs via YAM expansion before should help, specifically. Yeah, exactly. Okay. Thank you, thank you, thank you. Okay, so there was one question about that I skipped before. So let me see. How you could query the data without using GenAI to do the query if the data is not in a tabular form. So what do you mean exactly here? If you want to discover information in text, or if you want to generate your own large language model, I mean, it's possible. Of course, we have an extension, is the Keras extension. You can build your own deep learning model. I did build a deep learning model a few years ago where I was generating lyrics for rap songs, and then I would rap them, right? And not me, the students would rap them. And yeah, I mean, you can do that. It's not too complicated, but then, of course, at the end, you end up with a result which is probably inferior to the GenAI. That's because the GenAI is trained on a much bigger data set than what I could find, for example, in rap songs. Those are generalist models, so lot of data that they have, used lots of data engineering and lots of years to assemble. And then, of course, they have a much bigger model. I could do it in 1 week, 2 days, I mean, something like that, but I can't spend 6 months on training a model to generate rap songs. So my customers will kill me if I do that. So this is a bit, but of course, you can do it. I mean, sure. And actually, I think my rap songs were nicer. I tried the comparison with what ChatGPT does, but I think they were nicer. Yes, yeah. So it depends on the problem, as I said. For my outliers, I was not happy with the GenAI stuff. Maybe it was possible to get better results if I had invested more time, but then why should I invest that much time if I know already how the other technique works? I just drag and drop the node, it executes in 2 seconds. I don't know. I think sometimes we are trying to overkill a bit using the GenAI. But I mean, yeah, for the RAG, for the text work nicely. So it depends a bit on the topic. Yeah. Yeah, so did I answer the question before? The next time I can present how I created the rap songs.
All right. Thank you so much, Rosaria, for your wonderful session. And thank you all for joining us today. And I hope to see you all soon again at our upcoming events. And you can join us on LinkedIn. I have shared all the links. Let me share it again. And if you have missed anything by chance, you can watch the recording on our YouTube channel. Let me ping all these links in a group chat. Please take a note of it. Yeah. So shall we close the call? Shall we close the call? Anybody has any more question? Yes, you were saying something.